Hi, hello you guys. Welcome back from Thanksgiving break to AMT 151 Aircraft Basic Electricity. I am going to, this is a recording for you guys to review the answers for the worksheet that I gave you guys prior to Thanksgiving break. So I'm going to go over the answers of those questions so that you guys can have those for review for your exam that will be a week from today. Next Monday will be the final in this class. On Wednesday, our next class lecture, I will do a review for the final, and then Monday will be, the final will be open Monday through Thursday, midnight, okay? So here's the worksheet that I gave you guys with all of the questions. I will go through this, and on the equations, I will explain the answer key and how those answers were found, okay? So a lot of these are multiple choice and they come directly from your ASA, a lot of these word questions, even some of the equation questions. A few of them are examples that were made up by other instructors or myself. So we'll start with number 1. Through which material will magnetic lines of force pass most readily? The answer to that, the correct answer to that is going to be soft iron. I will take just iron as well, just for your reference. You guys are not turning in these worksheets. This is for you to study from, but that is the answer. Number 2, the basis for transformer operation in the use of alternating current is mutual inductance. The answer is mutual inductance. Number 3, the answer is A. When more than 2 inductors of different inductances are connected in parallel in a circuit, the total inductance is A, less than the inductance of the lowest rated inductor. Number 4, when different rated capacitors are connected in series in a circuit, the total capacitance is A, less than the capacitance of the lowest rated capacitor. Number 5, what is the total capacitance of a circuit containing 3 capacitors with capacitances of 0.25 microfarad, 0.03 microfarad, and 0.12 microfarad? So this problem is expecting you to use the formula of capacitances, the total sum of capacitances. Okay, so the correct answer is 0.4 microfarads is the total capacitance in that example. And here in the answer key, I just added all 3 of those capacitances. Number 6, the term that describes the combined resistive forces in an AC circuit is impedance. The answer is impedance. Number 7, when calculating power in a reactive or inductive AC circuit, the true power is C, less than the apparent power. Number 8, when different rated capacitors are connected in parallel in a circuit, the total capacitance is C, equal to the sum of all the capacitances. That's when capacitors are connected in parallel. Number 9, the opposition offered by a coil to the flow of alternating current is called, in this case, disregarding resistance, and that is called reactance, the reactance. Number 10, the answer is D, frequency and inductance. An increase in which of the following factors will cause an increase in the inductive reactance circuit? And the answer is D, frequency and inductance. Number 11, what happens to the current in a voltage step-up transformer with a ratio of 1 to 4? And that is A, the current is stepped down by a 1 to 4 ratio. Number 12, the answer is A. Transfer of electric energy from one circuit to another without the aid of electrical connections is called induction. 13, when inductors are connected in series in a circuit, the total inductance is, the answer is C, equal to the sum of the individual inductances. And in parentheses there, where the magnetic fields of each inductor do not affect the others. Okay, now the last half of this worksheet was the majority of the equation problems. So starting with number 14, what is the total capacitance of a certain circuit containing 3 capacitors with capacitances of 0.02 microfarad, 0.5 microfarad, and 0.10 microfarad? So what we want to find is the capacitance total. You know that these are connected in series because your formula here is your capacitance in series formula. So over here I wrote, you have the explanation beginning with your fractions. So 1 over your capacitances, 1 over 0.02 plus 1 over 0.5 plus 1 over 0.1. And that comes out to 1 over 0.02 equals 50. You divide that out. 1 over 0.5 gives us 2. And 1 over 0.1 gives us 10. That's a total of 62. And we can't forget to do the last step there, where we are going to divide 1 by 62 to give us 0.01613 microfarads. And just a note here, I don't think I had the correct answer listed. This was one of your questions on your quiz on Wednesday prior to break, and I don't think I had the correct answer listed on there. So anyone that did not receive credit for that, I will go back and correct that. I have not done that. I have not done so yet. I just realized that when I was looking through the quiz today. Okay. So that's your answer there for that equation. Total capacitance is 0.01613 microfarads. Number 15. I think we've seen this problem a couple of times. I know that it's in your ASA test guide. I can't remember if I might have had this on a quiz or an example for you guys. What is the impedance of an AC series circuit consisting of an inductor with a reactance of 10 ohms, a capacitor with a reactance of 4 ohms, and a resistor with a reactance of 8 ohms? Okay, and you have your formula here for your impedance in AC series circuits. So all you're going to do is plug in the information, which I described here. Our resistance is 8 ohms, so we have that here, and 8 squared plus 10 minus 4, which was our inductive reactances first, and our minus our capacitive reactance. So our inductive reactance was 10, our capacitive reactance was 4 squared, all taking the square root of. You calculate that out, that gives you 64. 8 squared is 64, 10 minus 4. I don't know why I put 62 there, that's a typo. Let me see if I can fix that. Okay, so here we have 64. 10 minus 4 gives us 6, and 6 squared gives us 36. If you add 64 and 36 together, that gives us 100. And we square root the whole thing, which gives us 10 ohms. And the answer is 10 ohms. 16, 17, and 18, the answer is 16, the answer is C. In an AC circuit, the effective voltage is less than the maximum instantaneous voltage. 17, unless otherwise specified, any values given for current or voltage in an AC circuit are assumed to be effective values. And 18, the amount of electricity a capacitor can store is directly proportional to the C, plate area, and inversely proportional to the distance between the plates. Number 19, using your capacitance total from question 5, calculate the capacitive reactance. So our capacitance total from question 5 was, but here's question 5. So the capacitive reactance, the capacitance total is 0.4 microfarads. So we're going to plug that into finding our capacitive reactance. And we have our equation. Capacitive reactance equals 1 over 2 pi Fc, where F is frequency and C is your capacitance total. Here, I've explained for you that this was our capacitance total from question 5. What we want to do first is convert microfarads to farads. In order to do that, we're going to multiply 0.4 times 10 to the negative 6. That's how we make microfarads into farads. And that's going to give us this really long decimal, 0.00004 farad. Now we take all of this information and plug it into our equation. 1 over 2 pi times 400, which is our frequency, times 0.0000, an extra 0 in here. Let's see. 0.0. I do have an extra. One, two, three, 4, 5. This one is actually missing a 0. 1, 2, 3, 4, 5, 6. Okay. So I'll say that again. So 1 over 2 pi times 400 with our frequency times 0.00004 farad. You multiply all of that out. Here I multiplied all of the bottom equation out, so 2 pi times our frequency times our capacitance in farads gives us 0.0010053. You're going to divide that by 1. 1 divided by 0.0010053 gives us 994.72 ohms. And the answer key gives you a rounded answer to about 995 ohms is our capacitive reactance in that equation. Okay, number 20. An AC sine wave has a time period of 2.5 milliseconds. What is the frequency? And you were given the formula, frequency equals 1 over time. Now if you remember that from lecture, we covered that briefly, that measurement of frequency. So the first thing you would want to do in this equation is you want to convert 2.5 milliseconds to seconds, because that is what we're going to plug into this equation. In order to do that, 1 millisecond equals 0.001 seconds. So we're going to multiply 2.5 times that, and that gives us 0.0025 seconds. That is 2.5 milliseconds converted into seconds. And then we're just going to plug that into our frequency equation. So 1 over 0.025 equals, that gives us 400 hertz. And that's our frequency. We have number 21, calculate the inductance total for figure 4, which is this clip here. It's a little messed up on my screen. The milli Henrys got cut off on this clip, so I tried to put a little text box in there. I don't know if that showed up on your guys' end or not, but in this format that I'm viewing, it's like moved over here. But they're all in milli Henrys. So if we want to calculate the inductance total of a parallel circuit, the formula we're going to use is the formula given, which is the 1 over L1 plus 1 over L2 plus 1 over L3. So here I described that for you. We have 1 over 10, which is our millihenries. 1 over 10 plus 1 over 18 plus 1 over 8. 1 over 10 equals 0.1. 1 over 18 equals 0.055 about. And 1 over 8 equals 0.125. You add all those together and you get 0.28 millihenries. And don't forget our last step where we are going to take 1 over 0.28 and divide that out, which gives us a total of 3.5714 millihenries. The answer key here rounds that to about 3.57 millihenries is the total inductance in that circuit. And lastly, problem 2, we want to calculate the total inductive reactance from the total inductance of number 21, which is just from the diagram or figure 4. So we're going to take all of that information we have and plug it into our formula, which is inductive reactance equals 2 pi times frequency times inductance. We already got our total inductance, but what we want to do is convert the millihenries to Henry. So we have 3.5714 millihenries. To make that Henry, we're going to move the decimal place 3 places to the left. So that gives us 0.0035714 Henry. We're going to plug all of that into our equation, which is 2 pi times 400, which is our frequency, times 0.00357. You multiply that all out, and that will give you 8.972 ohms is the total inductive reactance. Your answer key here rounds that out to 8.97 ohms. Okay, so that is the answer key for your guys' worksheet. I am sure that will help many of you with studying. Continue to look into some of those example problems. Your quiz today will have 2 of the problems off of your worksheet for you to complete. If you did not do so well on the quiz from last Wednesday from the worksheet without having the answer key, then I'm sure that this one will help your grade with having the answer key today. Make sure that you guys understand how to complete these problems, when you need to convert, and stuff like that. You typically always, if you're looking for inductive reactance, a big thing to remember is these inductive reactance and capacitive reactance equations. When you get your inductance or capacitance total, you want to, if you're going to plug it into the reactance equation, you want to be able to convert that to the base form of measurement. So for example, we converted this microfarad back to farad. Okay, so you definitely need to remember when that is necessary. In the reactance equations, that will be required. So that's it for lecture today. I just wanted to go over the answer key, continue to practice those problems, and then on Wednesday I will have a lecture posting for a review for our final that will be on Monday. You can email me if you have any questions about that, not so much about the final, but about the equations in this worksheet. I will correct that question on the quiz from Wednesday, and I will do a review on the final on Wednesday coming up. I'll do a review of what questions will be on there, how many questions will be ASA, how many equation questions you'll have, and some specific subject matter that you guys will want to review for the final. Okay? So that is it for today.